We would all like to help the environment, but can I really make a difference? After all, I can't afford to just go buy a hybrid car. I can't afford to replace all the windows in my home. I can't even afford to put a high efficiency furnace in my home. So, can I really make a difference? The answer is, of course I can. But in order to be most effective, I have to start thinking small. Huh? Think small? Isn't that the opposite of what we need to do? After all, isn't everyone looking to make big changes for the environment? Aren't they all talking about how we are in crisis? And we have to make big changes right now. Yes, they are. And the question is, how's that working out for them? We've been running in crisis mode for decades. We've moved from acid rain to PCPs and the ozone layer to greenhouse gases. As soon as we finish one crisis, we're on to the next. What's worse is that sometimes we even create the next crisis while solving the current one. We have to stop reacting in panic mode. So rather than waiting for the next big thing, let's take some responsibility and look for the next little thing. After all, it is much easier for us to implement a small change than a big one. What kind of small changes am I talking about? Well, how about turning off the lights when we're not in the room? Yeah, I know. We all know that one. After all, our parents told it to us for years. On top of that, what difference could that one little light really make? Well, let's examine what a difference it can make just in terms of carbon dioxide emissions. Not all of the other harmful emissions that also occur as a result of leaving that light on. Now, according to the 2000 census, there were 105,480,101 households in the United States. Now, let's suppose that just 1% of them left a light on. Let's see, 1% of that 105,480,101 households is 1,054,801 households. That's still quite a few. Now let's also suppose that those homes were also using low power consumption bulbs, commonly referred to as compact efficient lights or EFLs. On average, these bulbs consume 17 watts of power, or just over a quarter of the power consumed by comparable 60-watt bulbs. Finally, let's also suppose that those homes only left the bulb on for an extra 5 minutes. That's hardly consequential. Well, 1,054,801 households times 17 watts per bulb times 5 minutes, or 1/12 of an hour, gives us 1,494,301 watt hours. Now you might be thinking two things right now. First of all, huh? I didn't sign up for math class when I clicked on this link. I understand. And it's actually just multiplication that we're doing. It's the measurement or units of watts and watts hours that makes it a bit overwhelming to some. You don't have to understand it all or all of the math. Just understand that the conclusions I'm going to show you are real. I didn't just make them up. The second thing you might be thinking is, you just said 1,494,301 watt hours. What's a watt hour? Well, a watt hour is just a measurement of how much electricity is being consumed. So we have 1,494,301 watt hours. We can also describe that as 1.494 megawatt hours, because mega simply means 1 million. Now, over 50% of the electricity in the United States comes from coal-fired generating plants. And believe it or not, when coal is burned, there is pollution. In fact, there are many pollutants. As I said before, we're only going to focus on one right now, one that's relatively benign when we interact with it. However, it does have the potential to change our climate, and that's carbon dioxide. Now, let's suppose that our 1% of the population is getting their electricity from the cleanest coal plant available. That would be the H.B. Robinson plant that in 2007 created 323 pounds of carbon dioxide for every megawatt hour of power. But wait, our careless 1% of the population didn't consume a megawatt hour. They consumed 1.494 megawatt hours. 1.494 megawatt hours times 323 pounds of carbon dioxide per megawatt hour gives us 483 pounds of carbon dioxide. That's 483 pounds of carbon dioxide that did not have to be there just because we didn't flick a light switch for 5 minutes. Unfortunately, that's not all the bad news. I'm sure you already know the numbers I used were unrealistic. I just wanted to show you what a difference even just 5 minutes would make. But how unlikely is it for just 1% of the population to leave a single bulb on for just 5 minutes? I'm going to use my best estimates while still trying to remain conservative. If you think any of my numbers are unrealistic, use your own. You'll still be astounded by the results. I would suggest that more like 90% of the households leave lights on that they don't need to. I'd also suggest that in the average household, at least 2 lights get left on for 45 minutes when they don't need to be. That's probably still pretty conservative, considering many fixtures have more than one bulb in them. Most homes are still buying old-fashioned lights because they seem to make economic sense. An old-fashioned bulb costs pennies, whereas an EFL may cost dollars. The point is, most people are using 60 or 100 watt bulbs. Finally, the H.B. Robinson generating plant is a bit of an exception. In fact, there are very few coal-fired plants that produce less than 2,000 pounds or 1 ton of carbon dioxide for every megawatt hour power produced. Now let's see. 90% of the households times 2 60-watt bulbs times 3/4 an hour equals 8,544 megawatt hours of power consumed, or 8,544 tons of carbon dioxide emissions. All because we couldn't be bothered to turn the lights off when we were in the room. That's per day. In a year, that would be 3,118,560 tons of extra carbon dioxide. Now remember, we were only talking about carbon dioxide emissions, none of the other pollutants that come from coal-fired plants. In addition, we weren't talking about the environmental impacts that occur because we had to extract additional coal from the ground or transport that additional coal to a generating station. What about light bulbs themselves? They burn out earlier than they need to be. The new ones need to be manufactured. They need to be transported. That all consumes additional resources just because we couldn't be bothered to flick a switch. Now, many people are holding out hope for wind turbines, solar panels, and other clean energy sources. Don't get me wrong. I love the idea of producing energy with alternative methods. But the average large-scale wind turbine produces less than 2 megawatts of power. Simplistically, that means at a minimum we would need 356 of them working continuously to produce the 1,844 megawatt hours consumed by our light bulbs. Each of these turbines costs between $1 and $1.5 million. That means it would cost $1/3 billion to manufacture and install the wind turbines just because we couldn't be bothered to flick a light switch. Let's transition towards clean energy. Yes, but at the same time we can conserve so much just by making small differences. And that's where you come in. Look for small changes that you can make. Tell your friends and family. Let's all work together. If we all do so, we can start making a big difference for the environment. If you'd like to know more small changes that you can make that are virtually effortless but will give the environment a big boost, please visit futureenvironment.org. Sign up for the newsletter and get the free report, 10 Simple Actions to Environmental Improvement. Tell your friends to do the same. Together, we can all make small changes that will make a big difference for our environment.